are two different types of functions. We have strictly greater than, so I'm going to have 4x plus 8 is strictly greater than 24, and 4x plus 8 is strictly greater than negative 24 are my two different forms. Okay, Jarrell, are you here? Jakeem, are you here?
Yeah.
All right, Jakeem, so I'm trying to get x by itself. What should I move away?
If I break the hero will kill
The 4.
my father.
So I could move the 4. That would be fine. How do I get rid of that 4?
I will stop.
Divide.
Yeah, I can divide by 4. Okay, so it cancels out here, and I'm left with x. And what's 8 divided by 4, Jakeem?
You say what?
8 divided by 4?
Oh, 2.
Yep. And what's 24 divided by 4?
6.
Perfect. Thank you very much. Okay, and then Jamarian, are you here?
Yeah.
All right, so Jamarian, what am I going to do over here? Oh, wait, I didn't finish. I'm sorry. Jamarian, do you want to finish this for me? How do I get the x by itself?
You gotta subtract 2.
Perfect. I'm going to squeeze it in, minus 2 minus 2. So I should get x is strictly greater than 4 for this one. Okay, thank you, Jamarian. I'll let you go now. Jarrell, are you here? Okay, Regina? Regina?
Yes.
All right, so what should I do to isolate x in this equation?
So isolate x from 8.
Well, yeah, we need to get rid of the 8 and also the 4. But we can start with 8.
Oh, don't you divide, I think, or subtract?
So yeah, so it depends on the operation. So what is going on between the x and the 8 right now?
It's adding.
Yeah, so we need to do the opposite.
So it's subtraction.
Perfect. Minus 8 minus 8. What's negative 24 minus 8?
Good question. Negative 24 minus 8.
Yes.
Is it negative 16 or is 16?
It should be negative because both of these are negative.
So it adds a net. So the equation, the answer is going to be negative?
Yes.
Okay, so it's negative 16 then.
So it's not negative 16 because we're like, it's like you owe somebody $24 and then you owe them 8 more.
So it's 20.
So it's like adding 24 and 8, but they're both negative. So what is 24 plus 8?
24 plus 8?
Yeah.
It's 20. It's 34.
Close. 32. And since they were both negative, we're going to make that final answer negative. So negative 32.
So when you have two negative, you add them together and then you, on the answer, you put a negative?
Yeah, you can do it. You can think of it that way.
Oh, okay.
Yeah. You're just combining both of these negative things, so you're making it more negative. You know what I mean?
Yeah, I understand now.
Perfect. Thank you. Daisy? Daisy, are you here?
Yeah.
So what do I do to get this x by itself? What's the very last step?
Divide by 4.
Perfect. So I'm going to divide by 4 on both sides. Okay, and what's a fourth of negative 32? Do you know?
A what?
What's negative 32 divided by 4?
Negative 8.
Yeah, so I'm going to get that. Ooh, I shouldn't write it that way. So then I should get a negative, or the x is going to be greater than negative 8. Thank you. Okay, so I have these two pieces. Okay, So I'm going to draw out my number line for this to see what that solution looks like. So I have a -8 and I have a 4. Okay, so I'm going to line those up. Both of these should have open circles because both of these were strictly greater than. It had no equal to sign. But it says it has to be greater than -8 and also greater than +4. Okay, so our number line is just going to look like this. We have one big thing stemming up from -8. Okay. Yes. Okay, so then we're going to do another example, and I'm going to try to go through this one pretty quickly so that we have time to get through all the notes, because there's one really good example at the end that I want you guys to see that has a little property. Okay, so I'm going to flip this page. I will post like the final copy of this when I'm done so that you can see it and recopy any questions. So this is example 3. Okay, so I have the absolute value of 4 minus 2x plus 3 is less than or equal to 25. Okay, so the first thing I've got to do is get the absolute value by itself. So I'm going to subtract 3. 25 minus 3 should be 22. Okay, and then I want to split it into my two pieces depending on what this is. So I'm going to have that 4 minus 2x is less than or equal to 22, and that 4 minus 2x, oops, is less than or equal to negative. Okay. So I'm going to first subtract 4 from each side over here. Okay, because the 4 is over here by itself and it's being added. Okay, the 4 is positive. So these cancel, and then I end up with negative 2x is less than or equal to 22 minus 4 should give me 18. And now I need to divide by a negative number. When I divide by a negative number, I flip this sign. Okay, so I should end up getting that x is greater than or equal to -9. So when we divide by a negative, we flip our inequality. Okay, so it went from here to there. Okay, so I'm going to highlight that so that you can see. So this one changed to this, and that's because of this property right here. Okay, and then we do essentially the same thing over here. Messed it up right off the bat. I should subtract 4. So -4 minus 4, and I get negative 2x is less than or equal to negative 22 minus 4 should give me negative 26. And I'm dividing by a negative number again. So I should flip my sign, and I get that x is greater than or equal to +13. Okay, so now when I draw my number line, I should get something a little different. So I have a value at -9. I have a value at 13. They both should be closed circles because they both have an equal to at the bottom. But x is greater than or equal to -9 here. And x is greater than or equal to 13 here. Okay. We have those two guys going up. So our answer would be really -9. It's going to make everything true. So x has to be at least greater than or equal to -9 for everything to work. Okay, and the very last example, so example 4. Oops, sorry. We're going to have the absolute value of 3x is less than or equal to -9. Now, can somebody see the problem with this right off the bat?
It ain't nothing to like subtract or something.
Well, that just means we don't have to do step 1. But Jamarian, while I have you, this is an absolute value, right?
Yeah.
Can absolute values ever be negative?
No.
So if this is a negative number, can this ever be smaller than that negative number?
No.
No. Very good. So this is no solutions. Okay.
So the absolute value can't be smaller than the like the number that's on the other side.
So basically, because this is a negative number and this has to be positive, we know that the equal to can't hold true because the positive can't equal a negative. But all the numbers that are smaller than -9, are they going to be negative or positive?
Positive.
So if I have a number line and I have -9 on it, which direction do I go to get numbers smaller than -9?
Oh, to the left.
Yeah. And an example would maybe be -10. So is anything in this direction going to be positive?
No.
No. So because -9 is not positive and nothing less than -9 will be positive, we have no solutions. Oops, I spelled must wrong. Must be positive. Okay, thank you very much. All right, but what if I did this instead? If I had the absolute value of 3x and it was greater than or equal to -9, could I have a solution there?
Yeah.
Yeah. Why?
Because it's greater than.
Yeah, positive is always going to be bigger than negative. Positive values are always bigger than negatives. Okay, so the answer to this one, oh, you guys can't see that, I'm sorry. Okay, so the answer to this one is actually all real numbers. So we symbolize all real numbers by this double bar R, and that means all real numbers. So no matter what I stick in here, the absolute value bars are going to force it to be positive and going to make it be bigger than -9. So any number can be x, and we get something bigger than -9. Okay, so those are the end of our notes for today. I will post an image of both sides of this sheet that we worked on. I will post the final video of today's lesson in case you were confused. And then today, your class